Okay, so let's talk about relational design in the new section. Before we talk about the slides, I have a reminder for you. So according to the schedule, we will have the stage 2 of the project to be due by this Friday in this week. So do please work on the stage 2 with your teammates, and you also need to have a submission. As to the materials to be submitted, please check the project description. We have a concrete description about the materials to be included in the stage 2 report. And the report should be also submitted to Canvas as a PDF document. Besides the project stage 2, we also have the deadline for homework 2 to be due by the next Friday. So do please start working on the assignment 2 right now. I think half of the question you should be able to do right now because it is based on the relational algebra we covered in the last week. In this week, we will talk about the relational design as well as next week. Then we have a lecture on the midterm overview for you, and we also have some suggestions and guidelines for you for preparing the midterm. As to the format for the midterm, I haven't decided yet. It really depends on your performance. According to the question asked by the students for either the homework or some other question asked via emails, I find many students don't watch the videos or don't work on the slides or the courses. If so, then we may need to consider the format for midterm. We will probably do the in-class in midterm if you don't work on this course, right? I need to provide you with some motivation to work on this course so you can learn something useful. Otherwise, if you accumulate all the videos and watch them at once, it will be not helpful for you at all. So please don't do so, right? It is harmful for you. And I think for most of you, you will only take the database code only once in your whole life. Do please work on this course. It can provide you with lots of useful and meaningful knowledge, which can be helpful for you for your future career. So do please work on this course and spend some time on the materials we cover in each class and also do the homeworks. And besides the homeworks and the project, I also provide you a link for the project hands-on tutorial. And this tutorial is for programming for websites with database as a backend. And however, this tutorial is for the Python. If you use Python as a programming language, you should be able to find this tutorial to be helpful for you. And if you work on some other programming languages, and you can also search online to find some other useful tutorials for you to work on your project. I also follow this tutorial as well when I learn how to program with the websites and as well with the database systems. I think this tutorial can be very helpful for me as well because I create my own website by using this knowledge I learned from this tutorial. I think it's a good time for you to learn some basic skills to program with database systems for the websites right now because we have no lectures on this. We have no hands-on lectures on this programming in this course. We'll focus on the theoretical knowledge about database systems. So therefore, you may need to find some tutorials online to do the programming by yourself. I think this tutorial is very helpful if you are using the Python as a language. Okay, so this is a tutorial and let me close this. So far, we have talked about so many different topics from the ER model to relational model, and then we'll talk about relational algebra as well as relational design, right, which will be covered in this week. I'd like to provide you with the diagram again we showed in the previous lectures about the organization of these different sections. You should know the logic among the organization of these topics in this course. So by following the diagram directions, because we are working on some real-world domain or applications, right? When we are designing our websites, we are working on some real-world applications, either for the social media or for the e-commerce websites or for some other websites you are interested in. And we are working on a real-world application problem, right? In these applications, normally we have very complicated information. This information can also be very diverse and very complex. And we plan to do the modeling of the real-world information into computers, right, in our database systems. We do so by modeling first, right? We need to have a modeling language to help us model this complicated information in a real-world application. Therefore, we talk about the ER model in the very beginning. ER model is a very powerful but a very easy model, right? In the ER model, we only need to draw some diagrams, the rectangles, the diamonds, the ovals, to represent the information we have, right? We don't need to consider about programming in the very beginning in the ER model, right? We just draw some diagrams. It is very easy to draw, and it is also very powerful. It can model almost all the information we have in the real-world applications. The ER diagram is very easy to draw. However, they are very far away from computers for storage. It is very hard to store the diagram in computers, right? Therefore, we need to have another modeling language to help us. It is called relational model. Relational model is also very powerful. However, it further simplifies the concepts in the model. We only have one single concept in the relational model. It is called a relation, right? Everything we have in the ER diagram should be translated into relations with a bunch of rules we cover in the lectures. We have talked about the translation rules for you already, right? Every structure in the ER diagram should be translated into relations. It is very simple, and we have only one single concept. It is called a relation, right? And relation will be the target for the following sections. We will ignore the real-world application, we ignore the complicated information, we ignore the ER model, the ER diagram, we also ignore the relational model. Everything in the following section will be focused on the relations. This is what we have right now, right? Relation is very easy to store in the computers because we can represent the relation with the tables very easily. So generally, we don't differentiate the relations versus tables in database systems. And based on relation, we may need to do some queries, right? And we can go to the next branch. We may need to do some queries. And to do query on the relation, we may need to have some languages. Before we talk about the SQL, this language, we need to provide a theoretical design of the query as well as language first, right? It is called relational algebra. With relational algebra, we can provide not so basic and derived operations to help us design queries on the relations, right? If you remember, in the previous week, we have talked about some basic operations, the union, the difference, the selection, projection, product, renaming, as well as some derived operations like the intersection as well as the complement, and we can further derive the joins, the theta join, equal join, and natural join, right? So they are all operations we can use to design some queries on relations. So this is the relational algebra. Based on relational algebra, we will need to further introduce the SQL after the midterm, and all the operations we have introduced already, we will have an implementation of them in SQL. Okay, so this will be introduced later. You see, everything we are talking about here will be based on the relations, right? And this is the next branch. However, the relation we can get from the translation, via the translation from the ER diagram, cannot be perfect. We may have some problems. We will show later, right? Because they have some problems, therefore we have a section on the relational design. In this section, we will provide a bunch of algorithms to help us further polish the relation we have. So this is called relational design. This section is very complicated and very hard, so please do prepare for this section. So via the relational design, from the relations we can further polish them to get the polished relations. This relation will be much better than the raw relation we can get here. So this is the polished relations. Actually, for the queries we will be working on, they will all be based on a polished relation instead for creating tables and also to design SQL to be introduced later. Okay, so this is the organization among different sections we have covered, from the ER model, relational model, to relational algebra, relational design, as well as to SQL. I hope you can follow the logic of the organizations of these sections. It will be helpful for you to know the big picture for database systems. And this week, we'll focus on relational design. This section is very complicated, very hard, so please do prepare and spend some time on this section to go over all the materials. Make sure you can follow these materials we cover in the lectures. Okay, so let's go back to the slides.